Hi dear students, today we are going to discuss the chapter chemical equilibrium, very important EAP set, main points first. So first, based on the direction, the reactions are classified into two types. So irreversible reactions, next reversible reactions. So what is irreversible reactions? Which can take place, the reactions which can take place only in one direction. If reactants are converted to only products, that reactions are called irreversible reactions. So examples precipitation reactions. Silver nitrate reacts with sodium chloride, aqueous forms silver chloride solid plus NaNO3 aqueous. It is not a reversible reaction, so irreversible. Second example, thermal decomposition reactions. KClO3, potassium chlorate on heating, potassium chloride and oxygen gas is formed. So it forms a solid and it is a irreversible reaction. So next, neutralization reactions. Acids reacts with bases, forms salt and water. They are also called neutralization reactions. They are irreversible reactions. Fourth one, combustion reactions. When metals or non-metals reacts with oxygen and combustion forms their oxides, they are called irreversible reactions. Next one, reversible reactions. That means the chemical reactions which can take place in both directions. That means reactants are converted to products are converted to reactants, forward direction, backward direction. If both are takes place, they are called reversible reactions. That means when reactants converted to products, product converted to reactants, at any stage equilibrium state is formed. So H2 reacts with I2, forms 2HI, only it in a closed vessel, because in open vessel the gases are evaporated. So calcium carbonate on heating forms CaO plus CO2 in closed vessel. So different examples. Haber's process is one of the example. N2 plus 3H2 forms 2NH3, Haber's process. Next, esterification. CH3COOH, acetic acid plus ethyl alcohol forms ester plus water. So that is another example. So at equilibrium state, rate of forward reaction is equal to rate of backward. Main points only I will tell. Rate of forward reaction is equal to rate of backward reaction when they are in equilibrium. Reactants and products are in equilibrium. So rate versus time graph. So it is the graph. First the reactants concentration more, after some time reactants concentration decreases. Products concentration 0, after some time products concentration increases. Both are reached at equilibrium. That state is called equilibrium state. Okay, note this. So next one, at equilibrium state, delta G is equal to 0, change in Gibbs energy. Actually delta G formula, delta G naught plus 2.303 RT log Kc. So if delta G is 0, delta G naught is equal to minus 2.303 RT log Kc. By using this formula, different problems are asked in the previous MSET. So very important. Next, Kc means equilibrium constant. What is equilibrium constant? A moles of A reacts with B moles of B, equilibrium with C moles of C and D moles of D. So what is Kc means? The ratio between the product of concentrations of products to product of concentrations of reactants, and their stoichiometric coefficients are raised to its powers. So concentration of C, concentration of D, its moles converted to their powers. So concentration of C power C, concentration of D power D by concentration of A power A, concentration of B power B at equilibrium, that is Kc. If at any stage of the reaction, product of concentrations of CD by AB, that is called QC. QC means reaction quotient. Only at equilibrium, that is called, the ratio is called equilibrium constant. At any stage of the reaction, that is called QC. So if QC is greater than Kc, that is backward reaction. If QC is more than the Kc, that is the reaction is favorable to backward direction. That's why backward reaction. If QC is less than Kc, that means Kc is more, that is forward reaction. If QC is equal to Kc, then the reaction is in equilibrium. So next, different types, homogeneous and heterogeneous equilibrium. Homogeneous equilibrium means reactants, for example, homogeneous equilibrium means reactants and products both are in the same phase. are in same state. So N2 reactant gaseous state, hydrogen gaseous state, ammonia gaseous state, all are in same phase, then it is called homogeneous. Homo means same phase. Heterogeneous equilibrium. Heterogeneous equilibrium means reactants and products, even any one is different, that is called heterogeneous equilibrium. Here solid, gas, or gas, solid, or gas, solid, gas. Whatever different phases are there, that is called heterogeneous equilibrium. Okay, note this. A moles of A plus B moles of B in equilibrium with C moles of C and D moles of D. So Kp is applicable for only gaseous reactants and products, that means gaseous reactions. So pressure, Kp means equilibrium constant in terms of pressure, Kc means equilibrium constant in terms of concentrations. So in terms of pressure, Pc power C into Pd power D by Pa power A into Pb power B. Stoichiometric coefficients are raised to its powers only. Next, relation between very important Kp and Kc. So Kp is equal to Kc into RT whole power delta n. So very important. If delta n equal to 0, then Kp is equal to Kc. If delta n greater than 0, then Kp greater than Kc. If delta n less than 0, then Kp less than Kc. So what is delta n? So delta n means number of moles of gaseous products minus number of moles of gaseous reactants. So here, for example, H2 plus I2 is equilibrium with 2Hi. The left side parts are called reactants. These are products. Gaseous products, how many products? 2 moles. So delta n is equal to 2 minus gaseous reactants, 1 mole H2, 1 mole I2. So 1 plus 1, 2 minus 2, 0. So Kp is equal to Kc. So next, N2 plus 3H2 is equilibrium with 2NH3. So number of moles of gaseous products, how many? 2 minus number of moles of reactants, here 1 mole, 3 moles, total 4 moles. 2 minus 4 minus 2, delta n negative. So delta n less than 0, that means delta n negative means Kp less than Kc. So like these examples. Okay, note this. So next one, equilibrium constant. Equilibrium constant independent on concentration, pressure, catalyst and volume of the vessel. So in which equilibrium constant depends? It depends on temperature and mode of writing the equation and stoichiometric coefficients. If Kc means equilibrium constant in terms of concentration is greater than 10 cube, 3 conditions. If Kc is greater than 10 cube, products predominate. If Kc is less than 10 power minus 3, reactants predominate. If Kc between 10 power minus 3 and 10 power 3, then both reactants and products are present. Next, very important conditions and for problems. A is equilibrium with B, then Kc is equal to K. For reverse reaction, B is equilibrium with C, then Kc is equal to reverse reaction 1 by K, reciprocal. Next, A is equilibrium with B, Kc is equal to K. If it is multiplying with 2, then Kc is equal to K square. If it is multiplying with half, then Kc is equal to K power 1 by 2. K power 1 by 2 means root K. If it is multiplying with n, Kc is equal to K power n. So like that. So next, third one, if A is equilibrium with B, Kc is equal to K1. B is equilibrium with C, Kc is equal to K2. Then what is the equilibrium reaction for the A is equilibrium with C? Then Kc is equal to. So if we add these two reactions, A is equilibrium with C is obtained. So see, A plus B is equilibrium with B plus C. B cancel, A equilibrium with C. So then addition of these two reactions, so this reaction is obtained. Then Kc values are multiplied. K1 into K2. If subtraction of these two reactions, if it is obtained, then Kc is equal to K1 by K2. So next, we know that K is equal to formula A into e power minus A by RT. Log K2 by, logarithm applied, different conditions, different temperatures. So log K2 by K1 is equal to delta H by 2.303 R into 1 by T1 minus 1 by T2. So very important one, note this. Okay, see the first question. At T kelvins, when 1 mole of X and 1 mole of Y are heated in 1 liter flask, 0.5 moles of Z is formed at the equilibrium. The Kc value of the reaction is. So for this reaction, X plus Y is equilibrium with Z plus A. Before the starting of the reaction, here x1 mole, y1 mole, there is no products, 0, 0. So at equilibrium, it dissociated into x, 1 minus x, 1 minus x. How many moles? 1 moles. That means how much dissociated, that number of moles are formed. So x dissociated, here 1 mole, x moles of Z is formed. So A also x moles of Z is formed. If here 2Z is present, 2x is formed. Here 3A is present, 3x is formed. Dissociation is x, the number of moles of Z is 1, so 1 into x, x. Next, 0.5 moles of Z is formed. That means Z is equal to 0.5. X is equal to 0.5. Here also x is equal to 0.5. So 1 minus 0.5. 1 minus 0.5. 1 minus 0.5 means 0.5. Here also 0.5, 0.5, 0.5. We know that Kc is equal to product of concentrations of products by product of concentrations of reactants. So 0.5 into 0.5 by 0.5 into 0.5. So all are 1 moles. That's why 0.5 into 0.5. If here 2 is present, 0.5 whole square. If 3 is present, 0.5 whole cube. So like that. So all are cancelled. So answer 1. Kc value 1. Option B. Next model. At T kelvins, Kc value for the reaction 1 by 3 N2 plus H2 is equilibrium with 2 by 3 and H3 is 50. Kc value 50. So first one, 1 by 3 N2 plus H2 is equilibrium with 2 by 3 and H3. So Kc is 50. So the Kc for the reaction 2 moles of ammonia is equilibrium with N2 plus 3H2. Here 2 by 3 moles of ammonia is product, but here reacted. For reverse reaction, that means 2 by 3 and H3 is equilibrium with reverse 1 by 3 and 2 plus H2. For reverse reaction, Kc is equal to 1 by 50. But here 2 moles of ammonia. But here 2 by 3 moles of ammonia. If it is multiplying with 3 into 2 by 3 and H3 is equilibrium with 3 by 3 and 2 plus 3H2. So Kc is equal to 3. Multiplying with 3 means Kc is equal to 1 by 50 whole power 1 by 3. Sorry, whole power 3. This 3 is converted to its powers. If 2 is there, power 2. So 3 cancel. 2NH3 is equilibrium with N2 plus 3H2. It is converted to 1 by 5. So 1 by 10 cube into 10 whole power. 1 by 5 into 10 whole cube. So 1 by 5 means 0.2 into 10 power minus 3 whole cube. 1 by 5, 0.2 into 10 power, 0.2 whole cube into 10 power minus 3. So this value is 0.008 into 10 power minus 3. So that is equal to 8 into 10 power minus 6. So answer B. Okay, note this. Okay, see the next question. For the formation of ammonia gas from its constituent elements, ammonia means NH3 gas, the Kp by Kc is. So for the formation of ammonia gas, so N2 reacts with H2, it forms ammonia NH3. So 3 hydrogens means 2 nitrogens means 2 NH3, 2 into 3 6 hydrogens, so 3H2. So N2 gas plus 3H2 gas forms ammonia gas. So what is the delta N? Delta N is equal to number of moles of gases products 2 minus number of moles of gases reactants 1 plus 3 products minus reactants. So 2 minus 4 minus 2. So what is the relation? Kp is equal to Kc into RT whole power delta N. So if Kp by Kc is equal to RT whole power delta N means minus 2. So that is equal to 1 by RT whole power 2. So Kp by Kc is equal to 1 by RT whole power 2. So 1 by RT whole power 2. So answer B. So next question, very easy. In which of the following reactions at equilibria, the position of the equilibria shifts towards the products if the total pressure is increased? So according to Le Chatelier principle is applicable here. So here volume 1 mole plus 3 moles, 4 moles volume decreases 2 moles. 4 moles is converted to 2 moles. Here 1 plus 1, 2 moles, 2 moles. 2 moles converted to 2 moles. Here 1 plus 1, 2 moles, 2 moles. Here also 2 moles converted to 2 moles. So here 1 plus 1, 2 moles, 2 moles. 2 moles are converted to 2 moles. So in which volume decreases? If you increase the pressure, the reaction shifts towards the volume decreasing side. Again I will tell, if you increase the pressure, the reaction shifts towards in which volume decreases, because pressure is inversely proportional to volume. If you increase the pressure, the reaction shifts towards the decreasing volume side. If you decrease the pressure, the reaction shifts towards the volume increasing side. In which volume decreases? So here 4 moles decreases to 2 moles. So here only volume decreases. That's why when you increase the total pressure, the reaction shifts towards decreasing volume side. So answer is 1. So remaining answers are wrong. Okay, answer C. So when increasing pressure means reaction shifts towards decreasing volume. So answer C. That means option 1. Okay, not this.